I hope you are having a good time. So, let's start with our Docker onboarding. Maybe I will wait for someone to join. Um, I would like to make a sound check if possible. Checking if the sound is okay, the music. If someone can please let me know how's the sound. Hope it's not too loud. So let's get it started. So yeah, this is some whiteboarding that I will use to do. So this is the first episode of hopefully many that will guide you through a simple way to the Docker platform. So I will also during the stream will leave here the timestamps to make the description for the YouTube afterwards. And I'm gonna start with just showing small slides from a talk that I was presenting in PHP Lisbon a few days ago. So yeah, I would like to explain Docker as I would like that someone would have explained it to me many years ago. So just for a second, if you've heard about it but never touched it, I want you to close your eyes or your ears. And the ones who have tried it and maybe regretted it because it was too hard or too complicated or how does this even work you meant to be, I want to remind you that there was also one day where you were afraid to ride a bicycle, yeah, because it was scaring when you haven't done it, until it was not scaring anymore. When you would ride for a few weeks, then you would be okay with that. And that's exactly how this is going to be. And hopefully I will make you on that. I will ease your journey with that. So what is Docker? So Docker is an open platform where we can build applications, share them, and run them in the form of containers. You probably have heard this term. So yeah, it's available for Mac and Windows and Linux. We have someone on the stream. Hello, Miguel. Boa tarde. Good afternoon in Portuguese. Hope you're doing okay. So, it's cross-platform, but the way I would recommend to run it in production is only in Linux, as is where it's running natively. But of course, for the development experience, we can use it anywhere. And it's very straightforward setup to just have it installed. And yeah, that's essentially this. We will put well, I would like you not to fill you with technicalities, but if you know virtual machines, yeah, there's one slight difference. I'll try to find. There we go. So it's all of these pictures are most likely showing the same, and what's happening here is that, whoa, it's too low on quality, so to see maybe this one. So yeah, when we have a virtual machine running an operating system inside our a sub operating system inside our host machine, we have our physical server, so to say, and then we have the hypervisor or our OS, right? Similar to the right, but it's just saying hypervisor because it's related to servers, yeah. And then underneath each virtual machine will have its own guest operating system. So this can be some Linux running or Windows or whatever, and then the VM will run another full entire different isolated operating system. And with containers it is much lighter, because we are getting the isolation because each container has its own world, let's call it like this. What happens is that the host machine has only one operating system, so the kernel is shared, which means that it's much faster to boot, much faster to stop, restart. So yeah, it's very slim in comparison with a virtual machine. The difference of running natively is for the most use cases just negligible. We can just forget that we are running in a container. So yeah, during the talk I've run a few commands just to show that basically in 3 commands we were able to put a server in production, running a full-blown full-stack application, but in this series we'll do it differently. Let us just go in a very small... Hey Kaneko, yeah, sorry, Kaneko has joined the stream, and it's 11k time, and yes it is. Welcome, and thank you guys for being there. So yeah, with Docker, we are getting an isolated environment where we can develop, package, and distribute our application. We get infrastructure as code because all of the details of our infrastructure can be living in text files inside our repository, so that's very cool. It's super flexible because you can bring your own taste of your own opinions about how you do stuff, your language, your framework of choice, you name it. You can customize almost everything, right? So it's super portable, as everything is stored in the repository. We can reproduce it anywhere and very easily port it between places. You can resort to hundreds, if not thousands of applications and infrastructure available in the Docker Hub. We will see what's that later. It's just, essentially, it's just a place where you download all these stuff from. So you can deploy in your traditional VPS or droplet or VM, how you want to call it. You just need Docker installed. I mean, deploy for production, right? Because you use it on your host machine or in CI, CD pipelines. So you can, this is just a point that you don't need to learn anything new. You just need this application, Docker installed. But also it will enable you a new world where you will be able to do serverless, AWS Lambdas, or run your containers in ECS or EKS for auto-scaling of your stuff. You don't care about infrastructure and they do it for you. So these platforms as a service like DigitalOcean also has, Google Cloud Platform, and more. And last but not least, almost forgot, it works on my machine. It will stop being a conversation because, well, yeah, everything will live in the repository, the infrastructure that it needs to run. So it's not guaranteed, because nothing is guaranteed for sure, but I'll call it 99% that your environment related issues will stop, right? So I'm going to make a comparison based explaining just for the sake of quick understanding, and after you start using this tool you will be onboarded, right? You will be able to understand the deeper concepts, but for now let's think it as something else, like a storytelling that will happen right now. So what was Docker again? An environment to develop and run applications. So can't we just think of this as a computer? So like if we go to the store and buy a new computer, someone has already installed some operating system that you will bring, right? So after, when we get the computer from the store, we run a few steps, right? Install software X, software Y, and so on. And for simplicity's sake, that's all we do. And after that, we can have a complete running system to develop. So what if someone in our team or someone from around the world wants to run the same software? Wouldn't this be possible to do? And the answer is yes, of course it is. If we go to the store and buy 50 computers more, we now need to reproduce all this environment. So there are tools that we can use to clone our entire hard disk to another computer. So like making a clone, and this would be a very tedious task, right? If we were to do this in the real life. But how can I delete this now? Okay, I think I did something not so good. There we go. So I was in 11. Whoopsie. Okay, there we go. We still didn't go. Oh, sorry. Okay, now we have it. So we already had these steps covered, right? So after we get the computer like we want, then we would have a new CD or image ready to share and repeat with multiple computers. So we have a list of things to take in consideration, and please remember, this is a storytelling. This is not the real stuff happening in your computer. It's just to make a point that when we get a new computer from the store, we can make a bunch of steps, and this is the said recipe, and we can make a snapshot of the entire hard drive, right? And we get an image that we can then later install into one or more physical computers. And of course, there's something to learn here. And what's that? Is that you already know everything that there is to know about Docker. The end. Thank you so much. And I'm really serious. You know it all now. And why do I say that? Because we understand all this list of steps. We make a snapshot from the hard drive. We get the CD or DVD or a pen drive that we can put in another computers to reproduce the environment. And essentially Docker will allow you to do the same. and we'll do hands-on with all these, but keep in mind just these concepts. All you have to know are three things for now. It's Dockerfile, image, and container. So what is this? The Dockerfile is the recipe where we will have lists of steps to run that are code, right? Hello, Andre. Thank you so much for the good wishing of a good stream, and I hope you enjoy it too. Thank you. Welcome, welcome. So, after we have the Dockerfile, we can do something similar to the snapshot of the real computer that is called build. So, what is this build? It's an execution of the Dockerfile that then will result in an image. And this image is, of course, something very portable. And this image, if we then execute it, right, we get one or more containers running. And that's it. Hopefully, I will just check the next slide. Yeah. And right now, I will stop here and let's put our hands on deck and see this stuff working. Yeah, because now it's more live, right? Cool. So let's start a new repo, I would say. This should be bigger. Can someone let me know if this is readable, please? So I have Docker installed. Please let me know if the font is good. Maybe I'll make it a little bit higher. Okay. So let's make a folder called simple Docker, right? And let's start with a new repo. So a new project, I mean. It will be a README file. And this is simple Docker. Cool. And I'm just going to start the repo. Okay, initial commit. GitHub repo create, and it's going to be push this repo to the GitHub repository. So I'll copy the description for this and we'll make it public, of course. Thank you, Miguel, for the feedback about the font size. So let's add the remote and push everything. And now we can see the repo. Whoop. View -- web. And I'll leave it in the description. You'll be able to visit and reproduce the steps. We will tag it and whatnot. So yeah, cool. So this is I don't know where it started, but let's say it was in the beginning. And we are at minute 19 and we are start tinkering with Docker, right? So what happens here? Docker is essentially a command line for now, and it's a command. There's a command we can run. It's called Docker, and there is much to go around. So let's take it one step at a time. Let's just see in relation to our analogy, right? We have Docker files, images, and containers. So what I'm going to do is to see if if is there anything running in my system, and there is. It's a Laravel project. I was not expecting this, so I will just stop everything. Let's get a clean state. Let's not worry about any of the commands right now. Let's just make Docker just with Docker PS, and we can see there are no containers running. So let's grab something from Docker Hub. There is the hello world that I would like to do, but the web hello world. So let me try to find it. I'm trying to. Doesn't matter. I will use this, and later on another one. So this is an image that is already in the Docker registry. But even so, let's do something even more tiny, and we'll understand things chronologically, like I've explained it to you. I think it's better. So we have Docker already, right? So what I'm going to do is a new Dockerfile, the recipe, remember? And cool. How should we start a Dockerfile? We need a base operating system, so we're going to start with from, and I'm going to use Ubuntu, and I'll separate it with a colon, and I'm going to use 2204. It's an available tag, and in here, in this operating system, I'm just going to run echo, no, not, sorry, command, I think it can be like this. Let me check. Echo hello simple Docker, right? So that Docker file from before is exactly what we are doing right now. We are doing this Docker file. We just have this operating system, and we are going to run a command when the container is running. We are not running it now. So what I'm going to do is the build of this Docker file, creating an image. So let's list running containers. I think I'll be better off doing it like this, right? And you can run Docker PS, right? Also, we're going to build an image, and we will build that by running docker build, and we need to give a name to the image. So let's tag it with -t, and I'm gonna just call it, instead of just like Ubuntu :2204, I'm going to do simple docker :latest. So this will be the tag, and I will instruct Docker to use the current directory to use as the context for the build. So it will find the Docker file, the README, that folder is going to find. So let's build it, and it's already built because the image 2204 is already done and already present locally, and command is just a small fraction millisecond to do, right? You can see the build steps. We have it cached because it's already locally. I will find it. Let's run docker image ls, it's not going to be empty, it will have a lot of them. So I will just grab the, not to have over bloated screen, we will just see images that have Ubuntu in there. So we can see we have one image called Ubuntu 2204. The let font size is too big. So yeah, there is a dangling image without a tag. Most likely is the same, but stuff happens behind the scenes. What it matters is this image is present in my machine, so it didn't need to download. So from this operating system, we said this is the base for our image, and we run this command. So now that I have built this, I also have an image with simple, right? So we have an image called simple docker latest, and that's it. We can now run that image. So if we head back, what we did, let's try to find maybe the other software so that I can whiteboard. What we did was that we had our Dockerfile in our system, right? Not so good, moment, sorry. We had a Dockerfile in our computer, and from this Dockerfile it was requiring this image and adding this command. So what it did, it went to Docker Hub on the cloud, and it sort of pulled Ubuntu 2204, right? And it did not, because we already have in cache in my machine. And now we took this image, this CD, and we built a new one and added a command to run instead of the default, right? And from there we have a new image that is called simple docker. So yeah, hopefully you got it. Please let me know some feedback. And what are we going to do now? We are going to run it. So let's run a container and let's do docker run image name, right? So let's docker run simple docker, and it has the tag latest. So we'll grab this command, we will run this image and clear the screen, and with a little bit of luck we ran it and we are echoing simple docker. But this is an error. What did I do? I did some mistake. Command echo hello simple docker. What am I doing wrong? Let me check. Yeah, this is the default command, so let's build it again. We now have a new version that with the modified, and now we will run it. Executable find. Don't we have echo? Should I do the updates? Let me just check something. Or sometimes is something related to these codes. let's build the image and run it. Yeah, so I think we should run a few commands more. Yeah, Miguel, I was thinking the same, but then typically I don't build them from hand, so I'm not sure. Oh yeah, we need to put the arguments in an array format, right? Thank you, Miguel. And the arguments come next. So we now ran this command inside Ubuntu 22.04. So that's it. For example, if we run ls-lah, if we were to run this, we build it again, and now we're going to run it, and we can see contents in a directory that is not this one, right? It's totally different. So it ran that command inside another operating system. So it's a little bit similar to having so if this is our host machine, it's like we ran, so I'm having macOS right here, and when we ran it, we just booted an Ubuntu 22.04, and we just ran the command echo or ls right inside there, and we've seen the output. Okay, cool. So we need something else now. We can run commands, right? So we need just not an empty operating system. And I think for the starters, we will start an application. How much time are we in? 32 minutes. Cool. I'm gonna cap it at 1 hour, right? And then we'll continue. Please let me know any questions. Whoa, when did I start tinkering? I forget, then I have to check. Start a simple application. So what we did here, we built the most simple image possible. Simple image. We ran it. That's it. We made a Dockerfile, right? We built with a Dockerfile. With the Dockerfile, we built the most possible simple image. We ran it, and we see the output. The possibly most simple image. And we ran it. So at minute 34, we're going to start a simple application. And this is where I'm going to resort to something else. I will have to find it. For the sakes of simplicity, I would say Node is a very easy case because it's just one process to serve. So I will try to find a very simple application with Express.js. There we go. And sure enough, cool. We will start this project. So we are going to have an index file, and inside we are pasting this code. We are going to the terminal. We are going to npm init Go. And now we have a package.json. So we need Express, I would say, right? No, we don't have it. We need it, right? So we are going to npm install Express. It will run pnpm under the hood. It's a package I recommend everyone to see, to check out. It's from Antfoo, Ni, and what it's going to do, it will allow you to use whatever JavaScript distribution it was used. So you can choose a default, and depending on the file in the root directory of the project, it will use what's there. So yeah, I totally recommend you to check that out. So it was what I ran, Ni Express. It used pnpm and installed the Express module. I think it's already there. Yep, it is. It was just indexing the files. So what this is going to do is going to require the Express, start a new application, and put it running in port 3000. It will send an hello world, and when it in the slash directory we are registering this route, and when we start the server in the port 3000 we will see some output in the console. So this ran inside my machine, and I'm also going to run inside is still in my machine, no Docker until now. So yeah, so npm start, it will run index.js, right? So npm run start, nr start, and what happened is that node in my machine, not Docker, started the application. We've seen the output, and we're going to check that out. We're gonna go to localhost 3000, and sure enough we see the hello world string. So just you can be sure, let's say hello to the simple Docker class, right? We don't have any monitor running for the changes, so we have to start again. And if we were to refresh right now, sure enough we see simple Docker. So, but now you ask, you are running this on your machine, how can we run it inside? So yeah, to run inside we need to run it in Docker. So let's do just that, step by step. So 38 minutes, and we have two browsers. Don't want to make this too much of a mess, I'm sorry for that if that's the case. So we can close this and start simple application in Node.js, and we're starting the container for such application. Cool. So right now we are going to use another distribution already complete with Node. I'm gonna go with the 16. It's not the latest LTS anymore, but it's still very I think it's the most popular right now, so I'm gonna go with a safe choice with that. And now we need something more. You remember that we were running our echo and ls inside this container, but this container is totally isolated from the host machine, right? So we need something. We have our project files, inside our host machine. So we have it in my folder, so /users/Patricio somewhere inside my code, blah blah blah. We have, let's call it like this. So we have the files in my machine in some folder, and we have the container running here. What we're going to do is, for the build of this Dockerfile, we are going to copy the contents into inside the machine to the container. So for starters, I'm just going to say that I want that the default directory workdir inside the container will be /app. Okay, and then I'm going to say copy root to the root or app directory is the same. So what's happening here is happening that you do remember this dot that we gave when we were building. Sorry, Miguel, I missed your chat. This content is perfect for noobs like me. Oh, and the later, thank you for that. It's yeah, we were all noobs someday. Yeah, and I think this is also how I would like to learn it the first time. So thank you that it fits you well. It suits you well. So this later, I didn't see it on time. So sorry, I don't know what you mean. If you can repeat. So yeah, when we were building this image, we said we want to build with this tag, with this name, and I will give you the current directory. This current directory is calling the context, the build context, right? So this context is the root that we have here, and we will copy everything into there. So what we're going to do now is exactly this. We just see it, let's see it step by step. So let's build again. Grab the command. I will build it again. And now it's going to pull the Node 16 image. For some reason it's not downloaded. Oh, you have to go now. Okay, Miguel. So thank you for joining, and you will catch the rest later, I guess. Let me know if you need something. Thank you so much for being here. Okay, downloading. So it's happening. What happened here? Yeah, we have a Dockerfile, and it's going to the Docker Hub. Let me pull a little bit. Yeah. So we have this Dockerfile. It needed Node 16, not Ubuntu, but it went to download it and then ran more commands on it, and it built the simple Docker image. And it, sure enough, it's already done. So the context, it was loaded after the pull. We defined that our workdir, the default, is /app, and we copied all the context to inside app. And should I remind you, the command, that the default command is ls, and see all hidden files in a human-friendly way. So we will now run again the simple Docker image, and sure enough, it output /app content because it's the default folder. And you might see that we have the git directory and .idea directory and even node modules. All these came from my machine, the host machine, and we don't want that. So that we don't put any trash to inside, we are going to do a Dockerignore file, just like a gitignore file that we should also do. And we will ignore node modules, we will ignore .idea, .vs code, .workspace, I don't remember how is that, doesn't matter. Also .git is not going to be copied. And yeah, that's it for now. I will just make a sensible copy to .gitignore. And I don't want neither of these also. So let's build it again. And let's run it again. And sure enough, now we don't have all that trash. Also, we don't have the node modules that is needed. So what we need to do is, after copying this, we'll just run npm install, right? If we'll be using npm. And yeah, basically that's it. So let's build it again. And now the npm install is running inside the container. Oh, it's done. So it's running, it's here using in my host machine a node models that is ignored. But then a new one will be created inside the container because we just ran npm install inside the container. So that's it. So if we were again to run the container that runs ls, we already see node modules installed inside the container. So with all the Ubuntu 22.04 version platform in place, right? So now we should run it, right? And to really run it, because you see, when we now do docker ps, there are no containers running. And why is that? Even though I ran it, that is simply because this command finished its job, so the container stopped, exited, and it's just stopped. But I will show you something. Let's do -a, see everything, and let's grab for simple so that we don't get many output. And as we see, we have one container that ran our code, and it was 50 seconds ago, and yeah, it's just not running anymore, but it still exists. So wanted to explain you more stuff, but I guess that will come later. What we're going to do now is let's run npm start so that we get this endpoint serving in port 3000. Simple, right? So let's build again our image, and we have it built. And now the start command is different, so let's run it once more, and notice that it's running node application. The output is stopped because it's attached to the process running, and yeah, it's going to be here displaying all the time. So that's it. Unless an exception is thrown and the process stops, it will be running indefinitely. So now, if we were to go run docker ps, now it's running and it's up for 30 seconds. So it's running a container with his ID. It's just a unique ID. Everything in Docker has a identifier, right? The containers, images, networks, volumes, and so on. And this is the container ID. It also has a name. If we don't specify a name, it just gives a friendly name. And some more information, right? Command, created, status, and ports. So this is exactly what we're looking for, because right now we have this example app listening in port 3000, but what does this mean? Because right now I will give it a little bit more space to our host machine. I will make it bigger, just so that we can have, maybe I exaggerated a little bit. So yeah. This is our container. It's running npm start, right? So from there, whoops, sorry, my butterfingers went wrong. Ah, damn it, I cannot touch it. Sorry, I'm experimenting with a tool. So right now, the container is listening in port 3000, but not the host OS, right? So if I were to go again to localhost 3000, I get no reply because, well, the application is running inside Docker and serving port 3000 inside. But notice that we are trying to reach port 3000 of the host machine. So I guess you're already figuring. Right now we're going to do a mapping so that all requests coming to the host machine on 3000 will come to 3000, or it can be 80 in the machine and 3000 in the container. It's as we would like. So I'm just going to stop this execution with Control C. Oh, but we cannot because I didn't attach the output. So never mind, let's just stop it. So let's run docker stop in another terminal, of course. We want to stop this container ID, and not only this, we can use just a few unique letters. If across all system there's not any other entity 78AE or 78A, it will stop that container. And sure enough, it stopped. Cool. So there's one more command to take in consideration. And let's stop a container. So docker stop container ID, right? Or first unique letters for convenience, for typing convenience. Whoop, convenience. Cool. And we're almost reaching 1 hour, so let's come back into our running command, and this time let's run it in a different way. So right now we are going to run this, but we will attach, well, let's probably show you docker run --help. So when we are running, we can run all these options, and now we are looking for, we could run detached and we would not see the output, would be in the background, right? But we want to see it. It's just that we want it to be interactive, so that our command Control C, for instance, would grab the session. Excuse me. Also, we want to publish container ports to the host, right? So there's one more, to be a sudo tty, so to get all the colors and the fluffy stuff from the shell. We'll do just that. So let's docker run minus I minus T or minus IT or dash. But now that we're using a word, we put two dashes, publish, or it can be minus P. And now let's say port 3000 from the host machine into the 3000 of the container. And let's run simple docker again, /latest. And I think it's time enough. In the Docker images, if we don't write latest, is going to add latest word for us. Take in consideration, it's very dangerous if we forget, because latest is just a string. It's not a pointer to the latest version. So if you want a latest version to upgrade, we have explicitly to build it and to pull it so we can use it, okay? For the sake of explicitity, I will leave it here anyway. So right now we should be able to Control-C and get out, right? And we did. And we see the colors and the fluffy stuff also. And we published the port. So let's run the same command again. Notice that we don't see any ports published for now. But if we were to run the command again, docker ps, let's compare, and we do have something now. So what was empty before, we can see now that we have this section. So from the host, we will listen in any address in the port 3000. We will map that requests into 3000 of the container. So that's it. If all went well, we should be able to now see in port 3000 simple docker. And this request is coming from the container. So yeah, we have reached a sweet spot for the first time, for the first lesson, so to speak. We will just do a little tweak here. We will stop it, and each time a request is incoming, we will console log something. Console log request incoming. So we changed the source code. We need to build the image again, right? So let's build it. Same command. Let's update. Run a container. But we also ran a container with extra options, right? So I will store it for you. Run a container with ports published. Left is host, right is container, and interactive with TTY. Okay, cool. So we're now going to run this, and it's running again. Oh, just to make it different, let's run it in port 80. I mean 80 from the machine, 3000 from the container. And that's it. Look or take in mind that server is still serving in 3000, but is the host machine pointing to 3000. So it's here that we have done through the port 80 going to 3000. So if all went well, we should go to the browser, do not get a response in 3000, but we'll get it in localhost 80. So yeah, this answer came from Node, and if we were to see the output, we see a request incoming, right? So I'll try to put it so we can see it. So each time I'm pressing refresh, look, it's coming the output on the console. So I think that is enough for today. We have reached the first hour, and I will ask you if you have any questions. While I'm organizing the stuff to close, hit some questions, of course. In the next episode, we will see how we can make this faster, of course, the development. Not faster, but also fast. We don't have to build every time we want to see differences, yeah? So we are going to see volumes. That will allow us to use files from the host machine inside the container. So I'm stopping the container, checking the differences, and okay, I think we have application, first application running with published ports. Whoops. So now I'm going to git push, and sure enough, git a repo view, and we have it all ready for you to see and use. Hey André, thank you so much for being there. Hope you have a cool weekend too. And I guess you were going to start with Docker, right? For your e-commerce platform. I'm not sure, sorry. I don't know if you started already, can't remember exactly. So, hope you will enjoy the streams, whatever, even if you are doing it or not. That's it, guys. Thank you so much for being there. I will hopefully stream during the next week a few times. Be sure to subscribe if you want to see. Oh, thank you, Miguel. Sorry. So be sure to subscribe if you want to receive notifications. I will try to make these with lots of episodes so that even later they can be referenced. So that's why I've been, of course, now I will do it after turning off the stream, but I will make an index so you can jump to the stuff that you want to see later on, and hopefully it will help you in this onboarding to Docker. João Gomes, thank you also for being there. You too, have a nice one, man. Thanks. Miguel kept watching on mobile, so that's cool. I hope you are enjoying, and yeah, this is very simple baby steps. Maybe it's the cool rhythm for some people that already had the first contact. Maybe it's a repeating, but let's make this easy for everyone, yeah? Thank you so much, guys. I hope to see you very soon. I'm looking for the button to close. And hopefully still tomorrow or Monday I'll do a new one. Where is that? Not sure. No problem. Okay, guys. Now that's it. Thank you so much. Thank you for being there. Happy coding. Happy weekend. Ciao. Bye.